Kotlin has elevated functions to what is oftentimes referred to as first-class citizens or first-class entities. What that basically means is that in Kotlin, you can treat a function the same way you would treat other types of data elements. So you can define and assign a function to a variable or pass it to another function or have it as a property inside of an object, define it inside of a class. Pretty much the same way you could do that with a string or a double or some other class type that you might define. Now, this actually opens up a lot of possibilities in Kotlin because it allows us to move away from the strict defining and instantiating of classes that we would have to do in, say, a Java context. Now you can define functionality strictly inside of a function without all the overhead of a class. So what does that look like? Well, a function is basically a definition that specifies an input, an output, and then has an associated function body which performs whatever operations you would like to perform. The simplest form is to simply say declare a variable, a reference, and we could go ahead and actually just give this a function body. So we could say that this is a function that accepts an integer that we'll call x, maybe another integer that we'll call y, and then this function will return x times y. That's what this function does. It takes two inputs specified here, and then the arrow basically says what follows is the body of the function. And this can actually have multiple lines, but if it's a single line, then this is the standard operation. The function that we're defining here is referred to as a lambda. It is an anonymous function. It's a function that does not have a name. When dealing with a lambda, the last statement of that lambda is automatically returned. So this function is going to return an integer because it is the result of an operation, an arithmetic operation performed on two integers. And we can actually test this. So we can call myfunc, which is a function, and we can pass in 5 and 6. Now the result of this is going to be returned to us, so we can print the result. And we should get, I imagine, 30. So this is the simplest case of defining a function, a lambda, assigning it to a reference, and then using that reference, calling that function using the variable name. Now, if it is that we wanted to say, declare this variable before assigning it a specific function, then just like any other reference that we were defining, we would have to specify the type. Kotlin is inferring the type of this variable based on the value being assigned to it. If this was going to happen later, then we would need to tell it what the type is. So what is the type of this function? So there is no overall function type in Kotlin. Instead, each unique function is its own type. So this variable will have the type of the function as defined. In this case, we want to give this a function that accepts two integers and returns an integer. In this scenario, we have to be explicit, at least with the return type. In in a way that we were not when we just defined the body. So here we can say, using parentheses, we define the inputs. So this is going to take an input of type int. I don't need a name this time for the reference. Another int, and it will return an int. That's the compatible function type for the function defined here. So now we can specify that my func is going to take this function, and then we can execute as we had previously, and we'll get the result we want. Now, defining a function type in this manner is useful throughout Kotlin. Essentially, it is the way that we specify the type of a function that we can expect later. So, for example, let us say that we had a regular named function. So we have a function called calculator. And the job of calculator is to accept an operation and then a set of operands and then execute the passed in function. So the operator in this scenario is going to be the function. So this named function called calculator is going to be passed in a function as an argument of type int, 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 and it will also accept two operands, x, which is of type int, and y, which is of type int. So this is 3 arguments: a function that we call operator, and then 2 integers, x and y. Then this calculator can simply say, well, we'll call operator on x and y. The calculator function does not know what this operation will be. It doesn't know what the body of that function will be. It only knows the signature of the function. It is a function that takes 2 integers and returns an integer. And since my func, as we've defined it here, is such a function, then we could call calculator with the values with my func and x and y. We don't have an x and y, but we can just pass in 2 integers. What do we get? We're not going to really get anything because it's simply executing here. If we wanted to return the result of this function, if we know that this function returns an integer, if we wanted to actually then return that, then we would say calculator returns an integer, and then we can return the result of operator. Then I could print the result of my calculator call, which will then give me, I imagine, 20.